going to begin talking about related rates. Before I get started, I'm going to talk about some basic notation I'm going to use. V, I'm going to say is volume, C is circumference, R is radius, T is time, and A is area. So what is meant when I write each one of these? Well, when I write dV over dt, I am talking about finding the derivative of the volume with respect to time. I'm not going to write each one of these, but I'll just say them. This one would be find the derivative of the circumference with respect to time. Number 3 would be the derivative of the radius with respect to time. The 4th one, the derivative of area with respect to time. The next one, the derivative of the volume. Derivative of volume with respect to the radius. The last two that I've written here is if I find out that the volume with respect, the derivative of the volume with respect to time is a positive number, I'm going to know that it's increasing. And number 7, if I find the derivative of something, in this case the derivative of the circumference with respect to time is a negative number, I'm going to know that it is decreasing. Here's the method that I'm going to use over and over again to be able to solve a related rates problems. Anytime I can draw a picture, I will, even though I'm the worst artist in the world. I'm going to make a picture for myself. I'm going to write down the given and the find. I'm going to figure out what formula is needed. Then I'm going to find the derivative. I'm going to plug in my known values, and I'm going to solve for the unknown value. I'm going to label my correct rate or units. All right, the first example I'm going to do is a pebble is being dropped into a calm pool of water. So here's going to be the pebble that's dropped, and the ripples are going out and around, creating these circles. It says if each ripple moves out from the center at a constant rate of 1 foot per second, what rate is the total area of the disturbed water increasing at the end of 4 seconds? A lot going on. That's why we need to use that method. Step 1 was pictured. Step 2 is to find the given. What are we given? And what are we trying to find? I'm going to search for what I'm given. I'm given that each ripple moves out from the center at a constant rate of 1 foot per second. Well, how would I denote that? Well, I'm talking about the radius of the circle and how the radius is changing with respect to time. And I can see that right here. 1 foot is talking about the radius, and then it's over time. So I'm talking about dr over dt. dr over dt is 1 foot per second. The next thing I have is actually the question. It says, what rate is the total area of the disturbed water increasing at the end of 4 seconds? So how is the area changing with respect to time? That's what I'm trying to find. When, this is the bar we're going to use for when the time is 4, when t is 4. So that's step number 2. I've written down the given and the find. 3 is figure out the formula that I need. Well, the area of a circle is area equals pi r squared. Step 4, differentiate that. We're going to differentiate this with respect to t. dA over dt, the derivative of a would just be dA over dt, is equal to 2 pi r. Remember, we're taking the derivative with respect to t, so I'm going to have dr over dt. Well, I'm trying to find where the area, what the dA over dt is when t is 4. Well, I need to plug in my known values. I only know that dr over dt is 1. Well, what is r at the end of 4 seconds? Well, remember, it's changing at 1 foot per second. So this is 4 seconds. So at the end of 4 seconds, my radius would be 4 as well. So that means my d over dt is equal to 8 pi, and that will be my final. My last video cut me off just a little too fast. The last thing I need to write on here is the label feet squared per second. Area is always defined as square, meters square, feet, whatever the case might be. And it's dA, so area over time. So there's why I have feet squared per second. Next example, we'll go through the process again, which is to draw a picture. I have a spherical balloon. Here's my balloon. It's being inflated so that its volume is increasing at a constant rate of 8 cubic feet per minute. So it's increasing again. Find the rate of increase of the radius when the radius is 3. So I've got my picture. I'm going to write down my given and my find. What am I given? Well, I see one number up here, 8 cubic feet per minute. That gives it a way of how I'm going to label it. Cubic feet would be volume. So I'm going to have dV, problems with my pen, sorry, dV over dt equals 8 cubic feet per minute. The find the rate of increase of the radius. So find dr over dt when the radius is 3. Step 3 is to find the formula needed. Well, the formula for volume of a sphere is 4/3 pi r cubed. Yes, you need to know that. The fourth step is to differentiate this. We are differentiating this with respect to time. So we're going to have dV over dt is equal to 4 pi, and problems again, 4 pi, boy, all kinds of issues. All right, let's see if it's going to work now. 4 pi r squared dr over dt. Again, we're taking the derivative with respect to time. That's the fourth step. Fifth step, plug in known values. Well, I know dV over dt because that was in my given, is 8. I have 4 pi. I'm supposed to figure this out when r is 3, so I'm going to plug in 3 for my radius. This will allow me to solve for dr over dt. So step 6, solve for the unknown value. I end up getting 9 times 4 is 36 pi times dr over dt equals 8. I'll divide by 36 pi on both sides. And I just need to label this now. Radius is always in just terms of feet. So I'm going to have the answer of 8 over 36 pi feet per, the time we're talking about is minutes in this case, so feet per minute. Next example of related rate, we have a ladder that's leaning against the house. So here's my house. Here's my ladder. And it says that it's a 25-foot ladder. If the base of the ladder is being pulled away from the house at a rate of 2 feet per second, how fast is the top moving down? When the base of the ladder is 15 feet from the wall. Alright, so it looks like we've created this triangle here. We'll get into that in a minute. Let's go ahead and figure out what we're given and what we're trying to find. We're given a couple different things. I'm going to go ahead and label this triangle as X, Y, and Z. And you guys will see that a little bit later why I'm going to choose those. Well, actually, I'll just talk about it now. The X, I'm choosing that because it's horizontal. The Y, I'm choosing that because it's vertical. And the Z just because it's in alphabetical order. So I am going to be given that dx over dt is equal to 2 foot per second. The change in my x with respect to time is 2 foot per second. I am also given that z equals 25. I am supposed to find the rate at which dy is changing when the base is down here, so that's x. when x is 15. As I said, we had a triangle. Well, this happens to be a right triangle. We're talking about the sides of the right triangle. So hopefully you're able to do step 3 and pick out the formula, which would be Pythagorean theorem. X squared plus y squared equals z squared. I actually know that z is 25. Fourth step, differentiate. Take the derivative of this. So the derivative with respect to time is 2x dx over dt plus 2y dy over dt equals the derivative of any constant is 0. We're finding dy over dt, so I'm going to get dy over dt by itself. I could plug in known values at this time too. I'm just going to go ahead and solve for dy over dt. dy over dt ends up being negative 2x dx over dt divided by 2y. The 2's actually cancel, and I'm going to go ahead and plug in my known values now. I might have done this a little out of the order that we're used to, but that's okay. X is equal to 15. Dx over dt is 2. And then we're supposed to put this over y. I nowhere can find y, but I know that back in my problem I had Pythagorean theorem. So I have a 15, y, and a 25 in my problem. Well, I know that this is a 15, 20, 25 right triangle, so I know that y is 20. You can also use Pythagorean theorem to solve that. That just takes too much time. So when I simplify dy over dt, I end up getting 3/2, and I'm going to label this as feet per second. I'm not talking about area or volume, so it's just plain old feet per second. In this next problem, it reads that we are going to, or that we know that point is moving along a curve, y equals x squared. We can draw a picture of that. It's really not necessary, but I will. So that dx over dt is 2 meters per second. We're supposed to find dy over dt when x is 3. This is flat out just right here for us. We know exactly what we are given and what we're supposed to find. We are given that dx over dt is equal to 2 meters per second, and we're supposed to find dy over dt when x is 3. Our formula is just our equation. We're going to take the derivative of that. The derivative of y with respect to time would be dy over dt equals 2x dx over dt. Plug in our known values. Well, we're supposed to find dy over dt. We have our x is 3, and we have our dx over dt is 2. So we end up getting 12, and we don't, oh yes, we do have a label. It's meters per second. That is our dy over dt. This one was pretty simple. The next one, it talks about the length of a rectangle is increasing. So I'm going to not even finish reading the problem. I'm going to draw my rectangle. So the length is increasing at 6 feet per minute, while its width is decreasing. Decreasing means I'm going to have to put a negative in front of there, so I'm going to go ahead and do that right now. Find the rate of change of the area when the length is 100 and the width is 30. So I was given a couple things. I was given that the length is changing, dl over dt, is changing at 6 feet per minute. And I was also given that the width was decreasing at 4 foot per minute. We are supposed to find the rate at which, oh goodness, sorry about that. The rate at which the area is changing. So find dA over dt when the length is 100 and the width is 30. Well, what is the area of a rectangle? Well, it's length times width. Well, I can take the derivative of this with respect to time. dA over dt is equal to, I have a product rule, must be careful. So first and second here, I've got the first term times the derivative of the second, which would be dw over dt, plus the second times the derivative of the first, which would be dl over dt. I'm finding dA over dt. I'm supposed to find that when L is 100, so I'm going to plug in 100. I know dW over dt was -4, plus I'm supposed to find this area changing when W is 30, and I know dL over dt is 6. So dA over dt ends up being -400 plus 180. Well, that's -220. Area is described as square units. So in this case, square feet, and the time is every minute. So the area is actually decreasing at 220 feet squared per minute in this problem. Sorry for the number of videos in this particular section. It's just easier for me to start a new video than continue on and run out of time. So what we're going to do is we're going to do a couple last problems really quickly. They're very, very straightforward, and sometimes people actually overcomplicate them because they are so straightforward. So we're going to be finding dy over dx in this, or dy over dt in this problem. And so what we're going to do is we're going to take the derivative 2x dx over dt, and I am taking the derivative with respect to t, plus 2y dy over dt equals 0. Plug in my values that I have. Well, I have that x is 3. I have this 2 out in front. I know dx over dt is 8. I know that I have a 2. I know that I'm supposed to use 4 for y. And I'm solving for dy over dt, so that's my variable. Multiply these together, I get 48 plus 8 dy over dt. That gives me 8 dy over dt equals -48. Divide by 8 on both sides, and I get -6 as my answer. There are no units on this, so we're finished. The next problem, it talks about finding dy over dt for the specified values of x. So I'll first just start out by taking the derivative of y with respect to t and the derivative of sine x with respect to t, which would be cosine x times dx over dt. So I'm going to find dy over dt for each part. So part A says, well, I would know dy over dt is equal to the cosine of x. Well, the x they want me to use is pi over 6. And I'm supposed to find, well, I know that dx over dt is 2 from the instructions up here. So I'm going to plug in 2. Well, the cosine of pi over 6 is the cosine of 30 degrees. The cosine of 30 degrees is square root of 3 over 2. I'll multiply that by 2, and I'll end up getting the square root of 3 for my answer for part A. Part B, still the same, dy over dt equals cosine. This time I'm plugging in pi over 4. I'm still using dx over dt as 2 from the directions up above. So dy over dt in part B is equal to the cosine of pi over 4, which is square root of 2 over 2. So I have square root of 2 over 2 times 2. Those cancel, and I'm left with square root of 2 for part B. Last section, part C. C, I'm going to have dy over dt equal to the same thing, except I'm going to be plugging in pi over 3. And I'm going to plug in 2 for my dx over dt again. This is 180 divided by 3, which is cosine of 60. Cosine of 60 is 1/2 times 2. So in part C, my answer is 1.